see if I can get to it. There's nothing to divide by, add to both sides, it's ready to go right away. So let's think about let's think about that. Forget the negative 8a for a second, minus 3. Let's focus on this. What can I take the absolute value of so that is greater than 11? Well, if I take the absolute value of 11, that doesn't work. But if I take the absolute value of any number greater than 11, it works. Just like if I take the absolute value of every number less than negative number, less than negative 11, it also works. So anything between negative 11 and 11 won't work. I don't know, pick any number. Negative 10, 9, 8. Put any number here. Put 7. Absolute value of 7 is 7. Is that greater than 11? It doesn't work. So any number between these two won't work. So we call that an OR problem, right? So we know that this guy over here, this fellow over here, oops, has to be two things. This has to be greater than 11 or less than negative 11. That's how we'll set up our inequality. So negative 8 minus 3 has to be here, right? Has to be what? Less than negative 11? Less than. Or negative 8 minus 3, in order for that to work, has to be, and look at the other side, right? Has to be greater than 11. So let's solve it now. Plus 3, plus 3. That goes away. I have, what is that? Negative 8. Negative 8a. We're going to divide both sides by negative 8, so therefore we're switching the sign. And it becomes, so for a, we can use values greater than 1, plug it in here, and they will work. So, and then we also have one more, so plus 3 again, plus 3. That goes away. Negative 8a greater than 14, divided both sides by negative 8. And again, we're going to switch the sign. That 14 divided by negative 8 becomes negative 1.75. So let's put that on number line. A has to be greater than 1, not including 1, going that way. So if you pick any value greater than 1, 2, 3, 4, pick one. Let's pick 2, for example. 2, if I plug it in here, negative 8 times 2 is negative 16. Negative 16 minus 3 is negative 19. Absolute value of that is 19, and that's definitely greater than 11. So numbers here work. And it also tells you that if you pick numbers less than 1.75, it also will work. Let's pick negative 2. Plug it in here. So these are the A values, right? Values for A. So negative 2 times negative 8 is positive 16. 16 minus 3 is 13, and the absolute value of that, which is 13, is definitely greater than 11. So you can try it, and then pick some numbers in between here. Let's pick 0, because it's between negative 175 and 1. 0 shouldn't work. Well, let's see. Negative 8 times 0 is 0. 0 minus 3 is negative 3. Absolute value negative 3, 3, and 3 is definitely not greater than 11. So again, you can try a few numbers, but if everything is good here, this should really represent the values of A that makes this inequality true. And then we have this, we can write it like this. It's 1, not inclusive, and it's going to positive infinity, not inclusive again. And then negative 1.75 this way, and we're going negative infinity. Okay, so this set of numbers and this set of numbers together represent all the values of A that you can plug in here. That's pretty much it. 16 we did yesterday, so 17 is 9, m minus 8, minus 10, less than 26, so we're going to do plus 10 first, plus 10 on both sides, get rid of that. So we get 9, m minus 8, less than 36, we're going to divide that by 9, to positive numbers, so we don't switch signs or anything, so that becomes less than 4. Alright, so again, let's take this over here. Imagine, let's start understanding, when does this happen? When is the absolute value of anything less than 4? Well, if I take the absolute value of 4, it's not going to work. And numbers greater than 4 also, obviously, it's not going to work. But 3 works, because 3 is 3 and 3 is less than 4. So all these numbers work. Up to, but not including, negative 4. So if we take the absolute value of any number between negative 4 and 4, and you plug it in here, that would be that will make that inequality true. So I need this, m minus 8, right? I need whatever I need a number in here, okay, to be between -4 and 4. So what can I multiply? Sorry, what can I replace m with? Subtract 8 so that eventually becomes less than 4 when I take the absolute value. And that's what we're doing. So this is, and again, that helps. You can write that. So m minus 8 has to be between 4 and -4. Right? This value has to be between those two. Well, plus 8, plus 8, plus 8. That goes away. M is isolated. So it's 12, and this is 4. So as long as you pick a number for M that is between 4 and 12, that will be true. So let's, first of all, let's graph that. Here's 4, here's 12. 4 and 12 are not included, but any number between in there. So let's try 5. 5 minus 8 is -3. Absolute value -3 is 3, which is definitely less than 4. Let's pick a number outside. Yeah? Let's pick a number over here. Let's try 0. 0 minus 8 is -8. Absolute value -8 is 8. Is 8 less than 4? So it doesn't work. Some numbers over here don't work, right? In this area don't work. Okay. And then if you want to, I don't know, just if you have time, pick a number on this side of 12. 20. 20 minus 8 is 12. Absolute value of 12 is 12, which is definitely not less than 4. So again, numbers to the right of 12 don't work. So the only numbers that work are numbers between 4 and 12, not including them. So I'm going to write it. And there it is. Wait, what that was? 17. So 18. X plus 8 plus 10 less than 55. We're going to do minus 10 first. Minus 10 first. That's 45. And then we have 9x plus 8, which we're going to now divide everything by 9, both sides. And we finally have what we want, our absolute value. Less than 5. Again, let's pull this to the side. Forget the x plus 8 right now. Let's just focus on this. When does this happen? What numbers can I plug in here? Yeah. Take the absolute value off. So 5 is definitely not going to work, right? 6 is not going to work, but 4 does, or 4.9999 works. 4, 3, 2, 1, 0, -1, -2, -3, -4, all the way up to, but not including, -5. So again, this is an AND problem. I think the AND problems are easier. So I need x plus 8 here, right, to be a number between -5 and 5. So now we got to figure out what values of x would make that true. What can I substitute here? Exchange the x for a value so that when I add to 8, it ends up being a number between -5 and 5. So that's what we're looking for. So x plus 8 has to be between 5 and what's the other one? -5. Plus 8 on both sides. So minus 8 on both sides. The 8's go away. X is isolated. Now we have -3 over here, and we have -13. So, just like the previous problem, -3, -13, circle, circle. So if you pick any number between -13 and -3 and replace it here, right? Add it to 8, it should be less than 5. So let's pick one. -10. -10 plus 8 is -2. -2 absolute value is 2, and 2 is less than 5. Works out nicely. Let's pick a number to the right here, just to make sure. Let's pick 0. 0 plus 8 is 8. 8, absolute value of 8 is 8, which is definitely not less than 5. So numbers on this side don't work. Pick a number on the left side here of 13. -100. -100 plus 8 is -92. Absolute value of -92 is 92, and 92 is definitely not less than 5. So you can tell numbers here don't work. Numbers here, the only numbers that work are here, right, between -13 and 13, and there. Was that 18? So that's 18. I forget which one. 19. Did we do 19? I think I took a picture. Yes, we did 19. Yes, we did 20. And we did 22. So I'm going to 21, which doesn't leave too much. 21, 2, 10b plus 7 minus 1 greater than 73. I'm going to add 1 to both sides. That goes away. greater than 74, 2, 10b plus 7, divide both sides by 2, and I finally have my absolute value isolated. 10b plus 7 greater than, oh, what is that, 37? Okay. So this is a greater than sign, right? So we can start thinking this is going to be an or. When is that true? So when is the absolute value of something greater than 37? Well, it's true if you pick numbers to the right of 37, right, and on the right side of the number line. And 36 won't work, 35, 34, none of those will work. But when you get to negative 37 and past negative 37, these numbers will also work. So in order for this to be true, this number here inside the absolute value symbols has to be a number greater than 37 or less than 37. So now our goal is to figure out what can I replace that, right? What do I multiply 10 times and then add 7 so that it's equal to greater than 37. So let's set up. So 10b plus 7 has to be less than negative 37, or the other, or 10b plus 7 has to be what? Greater than 37. Well, let's do the first one. Minus 7 on both sides. That's negative 30. And then 10b comes down. Divide by 10. And b is less than negative 3. Here, minus 7 again. Minus 7. Oops, I did this wrong. I apologize. So this is negative 37. Negative 7 is negative 44. And divide by 10. Sorry. So that means negative 4.4. Apologies. Over here, minus 7, so that's greater than 30. That goes away. 10b, divide both sides by 10, and b has to be greater than 3. So let's what do you call, graph that. So values of b that we can use has to be greater than 3, so let's do that. Or less than negative 4.4. All right, so let's try it out. Actually, let's try a number between let's try one that doesn't work. Pick a number between negative 4.4 and 3. Let's try 0. Take that 0, plug it in here. 10 times 0 is 0. 0 plus 7 is 7. Is the absolute value of 7 greater than 37? No. So we already one little proof that number of a number here that doesn't work. Well, pick a number to the right of 3. Let's pick 5. 10 times 5 is 50. 50 plus 7 is 57. And 57, absolute value of that is definitely greater than 37. So proof that numbers to the right of 3 work. So let's pick a number to the left of negative 4.4. Let's pick negative 10. Negative 10 times 10 is negative 100. Negative 100 plus 97 is negative 93. Absolute value of that is 93. And 93 is greater than 37. So numbers on this side works. So let's write that, and it becomes like that. And on this side, negative 4.4, and goes to negative infinity. But we can't include it, so the last number, there's no last number, so that's why we put the parentheses there. Okay. What number is this? 20. Was that 21? No, 37. Hang on a second. I have no idea what number this is. One second. This is 21 again. Right, so 22 was done. So let's go to 23. 4, 6 minus 2a plus 8 less or equal to 24. Let's see, minus 8. 4 absolute times the absolute value of 6 minus 2a less or equal to, what is that, 16. Divide both sides by 4. We find leftover is what we want. Absolute value of 6 minus 2 times a less or equal to 4. So now I can start solving my problem. So again, let's start thinking about this. When is that true? Well, that's true. So it's It's a less than. It's a less problem, right? Less than problem. So I know that's going to be an and problem. I'm already start setting it up. So the only time this will work if that number, this number inside the absolute value symbol, has to be a number between 4, and 4 in this case works, and all the way up to -4. So any number between -4 and 4, you plug it, you put it in here, it works, right? So how does that help me? That will help me set up my problem. So I know the value of this right here, right? Whatever you plug, you substitute a with, multiply by 2, and then 6 minus that product has to be between -4 and 4, because otherwise it's not going to come true. Oh, so if it's an AND problem, I think, like I said before, I think it's the easier one. So it has to be between 4 and -4. So this value over here has to be between 4 and -4. So now I can start solving. So let's do plus -6 on both sides. On all sides. That goes away. This is -10, less or equal to -2a, which is less or equal to -2. Now we're going to divide everything by -2. And because we're dividing by a negative number, guess what? Things will change. So that's going to be 5, which is greater than b, which is greater than 1. Okay, so our number here is going to be a number between 5, inclusive, and 1. All right, so I can pick any number between 1 and 5, including 1 and 5, and plug it in here, and we'll get it true. So let's see if we have it right first of all. So let's pick 1. 2 times 1 is 2, so 6 minus 2 is 4. 4 is less or equal to 4. Good, let me pick another one. Let me pick, I don't know, we pick 1. Let me pick 3. 2 times 3 is 6, right? So 6 minus 6 is 0. Is 0 less or equal to 4? Yes. Let me pick a number left of 1. Let me pick 0. 2 times 0 is 0. 6 minus 0 is 6. Is 6 less, the absolute value of 6 less or equal to 4? No. So numbers here don't work. Let me pick a number to the right of 5. I don't know, 10. 2 times 10 is 20. 6 minus 20 is -14. Absolute value of -14 is 14. Is 14 less or equal to 4? Also a no. So we tried numbers here. We tried numbers between 1 and 5, which worked. So I put an X. That doesn't work. Numbers inside here worked. And numbers to the right of 5 didn't work. Okay, so this one we use brackets because it's inclusive. 1 actually is part of the solution. And then 5 is also part of the solution, so we use brackets. Okay. What number was this? 23. Okay. 29, 24. 9, 3n minus 2 plus 6 greater than 51. Minus 6 on both sides. We got 45 over here. We got 9. 3n minus 2. Divide by 9. Divide by 9. 3n minus 2 greater than 5. Okay, well, put a blank one, start thinking. When does this happen? When is the absolute value of something greater than 5? Well, it's greater than 5, so again, by now you should know that this is going to be an OR problem, right? So, I can use numbers greater than 5. Put any number greater than 5 over here. That works. 6, 7, 8, 9, 10, 5.1, 5.0001, right? As well as numbers less than 5. 5.2, 5.3, negative 5.1, negative 5.2, negative 10, negative 20. Put it in here again. Take the absolute value. And the answer will be greater than 5. So, we need to now find what value, what can I multiply by 3, and then subtract 2 to be greater than 5, right? We have to find the values of n. So we know that this guy over here, this thing over here, has to be two things. One, that has to be a number less than 5, negative 5, I'm sorry, or 3n minus 2 has to be a number greater than 5. Plus 2 goes away. 3n less than negative 3. Divide both sides by 3. Let me bring this down a little bit. Oh, not too much. Divide both sides by 3. N is less than negative 1. Or here we do plus 2 again. Plus 2. That goes away. We get 3n greater than 7. Divide both sides by 3. And n equals 2 1/3. Okay. Oh, sorry, 2 1/3. So let's graph our solution. So our solution, as long as you pick a value that is greater than 2 1/3 for n, or a value less than negative 1 for n again, substitute the n with, and then you'll be okay. So just, again, let me pick a number between negative 1 and 2 1/3. Let me pick 0. 3 times 0 is 0. 0 minus 2 is negative 2. Negative 2 absolute value is 2, and that's definitely not greater than 5. So we tried a number here. It didn't work. Let me try a number to the right of 2 1/3. Let me pick 3. 3 times 3 is 9. 9 minus 2 is 7. Sorry, 9 minus 2 is 7. Absolute value of 7 is 7, which is greater than 5. So this side, check. Pick a number to the left of negative 1. Negative 2. 3 times negative 2 is negative 6. Negative 6 minus 2 is negative 8. Absolute value of that is 8, which is definitely greater than 5. Check. So we want 2 1/3. If I keep writing 2, not inclusive, it goes all the way to infinity. And on the other side, we have negative 1, not including negative 1, and we're going to negative infinity. So that's just the notation for that. So that's it. 25, 3 plus 4, absolute value of 3x plus 7 greater or equal to negative 89. Oh, I think I like this problem. Minus 3. That goes away. 4, 3x plus 7 greater or equal to negative 92. Divide that by 4. So that goes away. We're left with 3x plus 7, which is greater or equal to, I don't know what that is. 92 divided by 4. 23. Negative 23. Okay, so this one is an easy problem. Now let's think about this for a second. Ignore the 3x plus 7. Think about this. When is the absolute value of a number greater than 23? What number can I put in here that makes it work? Well, 1 works, 2, 3, 4, 5. The absolute value of anything is always a positive number, right? So it will always be greater than a negative number. Okay. Another way of thinking about this is there a number that I can put in there that doesn't work? Think about a number that you can put in here that will not work. Yeah, it just won't happen, right? So in this case, we're done. We don't even have to complete this because it doesn't matter what I put here for x and multiply it by 3 and plus 7 and then take the absolute value. It doesn't matter what it's going to be. Whatever it is going to be a positive number. Okay, or even 0, right? Which is still greater than negative 23. So the answer to this is all real numbers. Every single number out there will make this true. Okay, and if I could write my pen, sorry, all real numbers. Okay, one more. That wasn't that bad. 9, absolute value of 1 plus 8n minus 3 greater or equal to 78. We'll do plus 3 on both sides. That goes away. 9, 1 plus 8n greater or equal to 81. Divide both sides by 9. And then we get 1 plus 8n absolute value greater than 9. Alright, so now I can start thinking. I eliminated everything. I'm only left with my absolute value. Okay, so let's start thinking. When is that true? When can I take the absolute value of a number so that is greater than 9? Well, it's a greater sign, so we know it's going to be an OR situation. So if it's greater than 9 or equal to 9, it's going to work. So if I put 9 in here, it works. 9.1, it works. 10. So any number to the right of 9 also works. But numbers also equal to 9. So if I put negative 9, sorry, if I put negative 9 here, it also works. And guess what? Every number less than that also works. Negative 20, I put it in here. Absolute value is 20. Is that greater than 9? Yes, it is. So all that works. So I need this guy here, right? So whatever you multiply 8 by, add to 1, whatever you do here, it has to be equal to a number less than 9 or equal to 9 or greater than 9 or equal to 9. So let's find those numbers. 1 plus 8n, right, has to be less than negative 9, or 1 plus 8n has to be greater, sorry, I forgot the equal sign, greater or equal to 9. Those are the two conditions. Minus 1 here, minus 1 over here, so we get 8n less or equal to negative 10. Divide both sides by, what is it, 8. And n equals negative 1.25, right? Negative 1.25. And on the other side, minus 1 again, minus 1. That goes away, that goes away. 8n is greater than or equal to 8. Divide both sides by 8. And is greater than 1. So let's graph that. This is all the values of n that I can replace n with to make this inequality true. So if you pick a number that says n is greater or equal to 1, so if you pick a number including 1 and anything above that, that will work. And it's also telling you that if you pick a number, sorry, if you pick negative 125 and every number less than that, it works. Let's try it. So let's pick a number between negative 1.25 and 1. And obviously I'm going to pick 0 because 0 is somewhere here. So 8 times 0 is 0. 0 plus 1 is 1. Is the absolute value of 1 greater or equal to 9? No. So these numbers don't work. Let me pick a number here. Let's pick 1. I can. 8 times 1 is 1. Sorry. 8 times 1 is 8. 8 plus 1 is 9. If the absolute value of 9 is 9, is 9 greater or equal to 9? Yes. So numbers here seem to work. And on the other side, let's pick an easy number, negative 2. 8 times negative 2 is negative 16. Negative 16 plus 1 is negative 15. And the absolute value of negative 15 is 15. Is 15 greater than 9 or equal to 9? Greater or equal to 9? Yes, it is. So numbers on this side also works. So 1 is included. So this, sorry, that should be a bracket. And we're going to infinity. And on this side, negative 1.25 is included. Bracket, and we're going to negative infinity. Okay, so that is it. It's really not that complicated. It takes a while, like I said, but it's not that bad.